Permanent Magnet Moving Coil (PMMC). A permanent magnet moving coil meter is also known as a D'Arsonval meter galvanometer is an instrument that allows to measure the current flowing through a coil by observing the coil's angular deflection in a uniform magnetic field. A PMMC meter places a coil of wire, that is conductor, in between two permanent magnets in order to create a stationary magnetic field. According to Faraday's laws of electromagnetic induction, current carrying conductor placed in a magnetic field will experience a force in the direction determined by Fleming's left hand rule. The magnitude of this force will be proportional to the amount of current through the wire. A pointer is attached to the end of the wire and it is put along a scale. When the torque or balance, the moving coil will stop and its angular deflection can be measured by the scale. If the permanent magnet field is uniform and the spring is linear, then the pointer deflection is also a linear. Hence, we can use this linear relationship to determine the amount of electrical current passing through the wire. PMMC instruments are only used for measurement the direct current. If we were to use alternate currents, the direction of current will be reversed during the negative half cycle and hence the direction of torque will be reversed. This result in the average of zero torque, hence no net movement against the scale. Despite of this, PMMC meters can accurately measure DC current. This is the diagram of PMMC meter, which contains the permanent magnet and aluminum former as with core, jewel bearing, weight balancing with the spring and top jewel bearing with attached with the pointer. The two poles of magnet are north and south and moving coil is attached with the pointer which indicates on the scale. The balancing weight and radial field will be between the permanent magnet. The construction of PMMC instrument. A PMMC equipment consists of two main parts. One is moving coil and permanent magnet along with other parts. All the parts are: one is magnetic system. The instrument consists of two high intensity, high corrosive force magnets of a big U-shaped magnet based on design. These magnets are made up of Alcomax and Alinco for higher coherence force and better field intensity. In many designs, an additional soft iron cylinder is placed in between the magnetic poles to make the field uniform while reducing air reluctance to increase the field strength. Second, moving coil. It is one of the main components of permanent magnet moving coil equipment and it is made up of copper coils wounded to the rectangular block in between the magnetic poles made up of aluminum. The rectangular block is called aluminum former pivoted to the jeweled bearing. It is what allows the coil to rotate freely. When current is passed through these coils, it receives a deflection in the field, which is then used to determine voltage or current magnitude. Non-metallic former like that, aluminum is used for current measurement, while metallic former with high electromagnetic damping is used to measure voltage. Control. Two springs made of phosphorus branch act as a control system for the permanent magnet moving coil. The springs are mounted on the jewel bearing of PMMC, providing the essential controlling torque. The controlling torque produced is mainly due to ribbon suspension. They opposes the force of deflection. So the electromagnetic force of moving coil came in equilibrium with the spring tension. This helps in keeping the pointer at a fixed position after an initial deflection. This control springs also serves the purpose of providing lead current paths in and out of the system. Fourth one is damping system. The damping torque is produced in the PMMC equipment by the movement of aluminum core in the magnetic field. It keeps the pointer at rest after the initial deflection. This helps in proper measurement without fluctuations. Due to the movement of the coil in the magnetic field, eddy current is produced in the aluminum former. This produces the damping force or torque which opposes the further motion of the coil. Slowly, the pointer deflection reduces and finally stops at a fixed position. Fifth part of PMMC meter is scale and the pointer. The pointer connected to the moving coil moves over a marked scale. The pointer moves along with the coil deflection to show readings marked on the scale. A pointer is a simple construction with lightweight design and twisted section to reduce parallax error. A parallax error can be further reduced by proper alignment of pointer blades to the initial scale. And working principle of PMMC instrument. When a current carrying conductor is placed in a magnetic field, it experiences a force perpendicular to the field of current by Fleming's left hand rule. This force tends to move the conductor. According to Fleming's left hand rule, if your left hand thumb, forefinger and middle finger at 90 degrees to each other, then the magnetic field would be along with the forefinger current across the middle while the force along the thumb. When current flows in the coil on the aluminum former, a magnetic field is produced in the coil in proportional to the current flow. This electromagnetic force along with the static magnetic field form the permanent magnet produces the deflection force in the coil. The spring then produces the controlling force to oppose further deflection. This helps in balancing the pointer. Then damping force is produced in the system by the movement of aluminum core in the magnetic field. It keeps the pointer fixed to a position after it reaches equilibrium with the controlling and deflection torque, providing better precision in the meter. Advantages of PMMC equipment. It is high weight to torque ratio. It has pointer deflection proportional to the current, which makes the scale more uniform over an arc of 270 degrees. It consumes much less power than other alternatives. No hysteresis loss. Unaffected by a stray magnetic field. Perfect equipment for onboard applications.